Welcome to Episode 4, Services and Networking. This is where Kubernetes transforms from a simple container runner into a true distributed system. By the end of this episode, you will understand exactly how pods find each other, how they talk to the outside world, and how to secure it all. Here's the core problem. Pods get a random IP address every single time they start. If you hardcode an IP to communicate with another service, it breaks the moment that pod restarts or gets rescheduled. This makes direct pod-to-pod IP communication completely unreliable in production. Kubernetes services solve this beautifully. Think of a service like a telephone exchange. You always dial the same number, and the exchange routes you to any available agent. Agents can join or leave freely, and you never care. A Kubernetes service gives your app that same stable virtual address. ClusterIP is the default service type. It creates a stable virtual IP accessible only inside the cluster, perfect for microservices talking to each other. Every pod matching the label selector is automatically pooled, and every service also gets a DNS name. So you simply call the service by name, no IP memorization needed. NodePort is how you expose an app to external traffic during development. It opens a port between 30,000 and 32,767 on every cluster node. Traffic comes in on the node port, hits the service on port 80, and forwards to your pods on port 8080. 3-layer routing, one seamless connection. For production, you have two options. LoadBalancer provisions a real cloud load balancer with a static IP, one per service. Simple but expensive at scale. Ingress is smarter. One load balancer handles all services by routing traffic based on host names or URL paths, with TLS termination built right in. CoreDNS is the cluster's phone book. Every service gets a full DNS name automatically, service name, .namespace, .svc, .cluster.local. Within the same namespace, you just use the short name. CoreDNS watches the API server and updates records in milliseconds whenever services are created or deleted. By default, every pod can talk to every other pod, which is a serious security risk. NetworkPolicy lets you write firewall rules for your pods. This example allows only the API server to connect to the database on port 5432 and denies all other incoming traffic to that database pod. How does it all work under the hood? kube-proxy runs on every single node. When your pod sends traffic to a service cluster IP, kube-proxy intercepts it at the Linux kernel level using iptables rules and rewrites the destination to a real pod IP. This happens entirely in the kernel, which means it's extremely fast. Here's your networking cheat sheet for daily use. Get services to see everything running. Expose a deployment instantly with one command. Describe to debug endpoints. Port forward is your absolute best friend for local testing without exposing anything externally. And check endpoints to diagnose why traffic might not be reaching your pods. Episode 4 is complete. You've mastered Kubernetes networking from the ClusterIP concept and DNS discovery, all the way to network policies and how kube-proxy works under the hood. In Episode 5, we tackle config maps and secrets, how to manage application configuration and sensitive data the right way. Subscribe, and we'll see you there.